Hello, this is Geometry Lesson 2.5, Reasoning in Algebra and Geometry. The objective for this lesson is that you will be able to connect reasoning in algebra and geometry. So this is actually kind of our introduction to proofs, starting with algebraic proofs today. Um, so, Algebraic properties of equality are what we use in geometry to kind of introduce our proofs, and we use them in our geometry proofs eventually as well. They help us to solve problems, and they help us justify each step you take, because proofs, what they do is they reason and they justify everything we do. So here are your basic properties of equality. I'm going to go one by one. The first one is the addition property of equality. And you can see it says, hey, if you have two numbers that are the same, A and B, then A plus C equals B plus C. If you add the same things to both sides, your equation is still equal. It's really useful when we're solving our two-step equations. Same thing with our subtraction property. It's very similar. If A equals B, then A minus C equals B minus C. So we will use those two a lot when we are moving around our constants and our equations, or maybe getting our variables on one side. Next, we have our multiplication and our division. Very similar as well. It says, hey, if A equals B, then A times C equals B times C. You can multiply both sides by the same thing. We do this sometimes if we have a fraction in front of our variable, and then we need to get rid of it. Division property, it says A equals B, and C is not 0. This is important because then A divided by C equals B divided by C. We can divide both sides by the same thing, and it's still balanced. We do this once again a lot of times when we're finishing solving for our variable and getting rid of our number out in front. The next four properties get a little bit different in their setup and how they work. So reflexive and symmetric property kind of go together. Reflexive property says, hey, A equals A, meaning something is equal to itself. And this is really useful when we're trying to sometimes introduce something in a proof before we use it somewhere else. We'll say, hey, it equals itself, and then we can kind of go from there. Symmetric property is really handy because it allows us to change the order. You can say if A equals B, then B equals A. Well, you can swap the order of your equation around like that, and things will still work just fine. Then we get into the transitive property. I think about this as my linking property. It behaves just like the law of syllogism. It says if A equals B and B equals C, then A equals C. You have that repetition of B, so you can skip it entirely and jump from the beginning all the way to the end of that property. And then next up here we have the substitution property. It says if A equals B, then B can replace A in any expression. So this allows us to say, hey, at the very beginning we were told x equals 10. I'm trying to solve for y. I can go plug that 10 in for x. We use this one pretty frequently in here as well. So I'm just going to walk you through real quick an example algebraic proof. It says solve the equation 3x plus 7 equals 16 using the properties of equality to justify each step. So first off, I'm going to write down what we have. And since, that was part of our problem, we call that the given. About 90% of the time, you're going to start your proofs with the given. And then we just kind of start to solve, but we only want to do one thing at a time. So if I follow my two-step rules, I'm going to subtract 7 from both sides, and I get 3x equals 9. Well, if we look back at those properties that we have, we just subtracted 7 from both sides. The one where you can subtract something from both sides, that's your subtraction property. So we would say, hey, this was our subtraction property that allowed us to go from the first line to the second line. So we put it next to the second line. And now if we keep going, we're going to get that x by itself and divide both sides by 3, and we get x is equal to 3. Well, if we look at what we just did, we divided both sides by 3. I check. That's what the division property does. You're dividing both sides by the same thing. So this was my division property that allowed me to get x equals 3. And that's just kind of how proofs start with our algebraic proofs. Now these aren't the only properties that we have that we use. These are the properties of equality. But we have a few more properties. I'm going to jump through some of this stuff pretty quick. This next part is the distributive property. You use this all the time. It allows us to distribute a coefficient through parentheses. And so this comes handy when we're simplifying or doing stuff like that. So we've got, hey, if A times quantity B plus C, that can turn into AB plus AC. That's the sum version, and there's a difference version. If you have A times the quantity B minus C, then that can become AB minus AC when you distribute the A through to both your terms. When we solve an equation, we're just using our deductive reasoning like Sherlock Holmes. We justify each step in our solution with a postulate property or a definition. Eventually, we're going to add some theorems to that as well. Sometimes when we're solving these equations, we want to combine like terms. So we can use the distributive property to justify that. We'll also let you write simplify down for that, or just write down combine like terms. But why you can technically use a distributive property, you can kind of see that demonstrated there. Alright, I'm going to stop the video here. This is just kind of your brief intro to our algebraic properties of equality and the beginning of proofs.